Hello and welcome. Today we will talk about the process of leukocyte migration through blood vessels to the site of inflammation. So now we have an inflammatory site where we need urgent supply of leukocytes to come over to the site of the inflammation because we have infective microbes, we have bacteria, we have viruses, we have fungi, we have a parasite, or we can have trauma, or we can have ultraviolet radiation, or maybe there's a chemical agent that caused a burn, or there's a bruise, or a contusion, or whatsoever that is causing that inflammation. So we need the leukocytes to come from the blood and arrive specifically and particularly to that particular site of inflammation. How do the leukocytes know that we need to stop here? You know, blood flow is very rapid. So how does the site of inflammation grab these leukocytes and cause them to leak out from the site of the inflammation? So today we will talk about what are the mechanical steps involved in the recruitment and the migration and the margination. You know, we have migration and margination. We need to first of all understand that in the blood we have red blood cells and we have plasma and we have white blood cells. White blood cells are much bigger and denser than red blood cells. That's why red blood cells are usually centered in the middle because they are traveling with high velocity, while the leukocytes, because they are more dense and they are bigger, they are usually a little bit peripherally. They are, alienated to the side of the laminar flow of the blood. Okay, so now let's say there is an injury, as we said, there's an inflammation. We said we begin with a normal cell that underwent an insult or a stressful stimuli. That stressful stimuli far surpassed the capacity of the built-in systems in the cell to overcome that or adapt to that stress, and now we have an injured cell. Rather, we have an irreversibly injured cell, and then we have a necrotic cell. Otherwise, if we have apoptotic cell death, we will not have inflammation. That's why we have a necrotic cell death that led to the spark of acute inflammation, what we have now. So now we are at the stage of actually suffering from an acute inflammation. There is an intruder. There is a stressful stimuli that needs to be, dealt with and abated and brought down, and we need to pave the path for healing and resolution. So what do? As I said, in the blood vessel, before we go to the diagram, in the blood vessel, what do we have? We have the blood flowing through, and we have red blood cells which are much smaller, running in the middle, while peripherally we have these white blood cells. What happens is the inflammatory process begins with the macrophages. We have resident, also known as sentinel immune cells, that are stationed in the tissue, in all our tissues. They are like police precincts. These police precincts, they detect these immune cells, these mast cells, macrophages, and dendritic cells. They detect with their receptors, these toll-like receptors. They detect, the polysaccharides, and they detect these sugars and polysaccharides and proteins that are on the surface of the microbes. They detect necrotic debris, and as soon as these dendritic cells, mast cells, and also the macrophages detect mechanically these signs of inflammation, that debris or that infective microbe, they immediately begin to send a signal. This signal is in the form of mediators, cytokines. So it begins with the cytokines released by mainly the macrophages
and sometimes dendritic cells and the mast cells, provided the time and the place in the body of where we are. But mainly it's the macrophages. They send cytokines like interleukin factors, like tumor necrosis factors, like interferons, like leukotrienes, like chemoattractants, like chemokines. They send these cytokines in the blood. These cytokines, what they do is they actually activate these flowing white blood cells. So these white blood cells, although they are running in the bloodstream, circulating and surveilling our body, they are actually in the inactive form. It's only when there's an inflammation and the release of those cytokines, what happens is these white blood cells, these monocytes and these leukocytes, and these neutrophils, mainly neutrophils, these neutrophils become activated. So the cytokines start to recruit and bind to the surface of these leukocytes, which causes them to gravitate to the site of the inflammation. We already talked about how the environment in the inflammation is already ready for the infiltration of these leukocytes to the site of the injury, because we talked about endothelial retraction. These cytokines released by the macrophages, they are in fact not only these cytokines, they are not only affecting the white blood cells, they are also affecting the endothelium. So they cause the endothelial cells to retract, and when the endothelial cells retract, they cause gaps known as interendothelial gaps, through which these leukocytes transmigrate and leak and exit the bloodstream into the site of the inflammation. So now what happens is we have receptors that begin to be expressed in the endothelium. When these cytokines are released by the macrophages during inflammation, the endothelium begins to retract and begins to express on the surface of itself these selectin proteins. These selectin proteins are receptors that bind, like hooks, that bind to the white blood cells and grab them and bring them to the site of and begin to roll, as we will see in a little bit, and bring them to the site where they will transmigrate through the interendothelial gaps. So what I need you to understand is that the first step is initiated by the macrophages. The macrophages, they send and they release cytokines. These cytokines interact with the endothelium. First and foremost, they cause the endothelium to retract, cause interendothelial gaps through which there's a permeability, through which these white blood cells will transmigrate. We will also have these cytokines that will bind to the surface receptors in the leukocytes and cause these leukocytes to marginalize and come closer to the sides of the blood vessels, close to where these interendothelial gaps are, where there's the damaged endothelium, so they can leak. So now let us look without further ado to what we have in the diagram. This is very important. So what we see here in the diagram, this is a blood vessel. What's in green is the extracellular matrix. And the purple stuff, that's our leukocyte of choice, is the neutrophil, and that's a perfect example because it is the major leukocyte that is active during inflammation. That's the neutrophil, and in the duration from the onset of the inflammation, we have the leukocytes or the neutrophils apparent in the first 24 hours. After 24 hours, we will no longer have neutrophils, we will have macrophages. That's why the first responders are the neutrophils. So as you see, the neutrophils begin, you see they have these green receptors, and these green receptors attach to receptors on the endothelium, and they begin to roll until they find the interendothelial gap where they transmigrate And what they do, they also possess metalloproteinases, these protease enzymes that degrade and damage the extracellular matrix in order to pave them for themselves the path so they can exit and travel through the extracellular matrix and go and digest microbes and digest debris and get rid of it properly. So now let's look closely at what we have here. Let's take a good look at what we have here. Okay, so we have the blood vessel, and we have the first process is known as rolling. And what happens is we have different kinds of selectin. It ends with actin because it detects sugars and polysaccharides and liposaccharides and proteins, glycoproteins that are on the surface of the leukocyte. So when there's inflammation, the cytokines will cause the transcription of proteins that are in fact receptors and express them on the surface of the endothelial cells that are closest to the site of inflammation. You see, this is the macrophage. It begins, this is step number one. This is the most important thing. This is the step number one. If it wasn't for this macrophage secreting chemokines and cytokines, we will not have inflammation. So they sent the cytokines and chemoattractants and chemokines, and these chemoattractants and chemokines will begin to bind to the receptors in the leukocytes. And when these chemokines, these chemoattractants bind to the surface of the leukocytes, mainly the neutrophils, they cause cytoskeletal rearrangements where actin and filaments will cause the filopodia to move to the site where there was a binding between the chemoattractant and the receptor at the surface of the leukocyte. And chemoattractants will continue binding to the site that will cause the leukocyte, mainly the neutrophils, to come closer and closer to the site of where the endothelial injury is. The endothelial injury will express three different types of selectins, mainly P-selectins, which are found on the surface of platelet cells and also the endothelium. There is E-selectins, and they are only found on the surface of the endothelium. And there is L-selectins, which are found only on the leukocytes. So you see green is the L-selectins, which are only found on the leukocytes. What happens is sometimes the ligand or the ligand would bind to the receptor, the P-selectin, and then the ligand will be here, and this will be the receptor. And sometimes the receptor will be here, and this will be the ligand. So the ligand at the surface of the neutrophil will bind the receptor at the surface of the endothelium. And then the ligand at the surface of the endothelium will bind the receptor at the surface of the neutrophil. And like that, it will be a process of rolling. This rolling process is very important for you to understand. What happens in rolling is, at the surface of the neutrophil, there will be ligands that are detectable by receptors on the endothelium, and on the endothelium there will be ligands that are detectable by receptors on the leukocytes, and on the leukocytes there are ligands detectable by receptors on the endothelium, and the endothelium has receptors that detect ligands on the endothelium, on the leukocyte. So the leukocyte has both. It has ligands detectable by endothelium receptors, and it has receptors that detect ligands on the endothelium. While the endothelium also has both. The endothelium has receptors that detect ligands on the neutrophil, and the endothelium also has ligands that are detected by receptors on the leukocyte. So you can see how the spinning happens. One time the ligand binds the receptor, the next time the receptor binds the ligand. The ligand binds receptor, receptor binds ligand. Ligand binds receptor, receptor binds ligand. So all you need to know is the P-selectin and the E-selectin and the L-selectins. They are important for the rolling process, where we marginalize these migrating leukocytes and cause them to roll, where one time the ligand will bind the receptor and the next time the receptor will bind the ligand. Sometimes a ligand on the surface of the leukocyte will bind the receptor on the surface of the endothelium. The next time a receptor on the leukocyte will bind a ligand on the endothelium. Then the ligand on the endothelium will bind a receptor on the a ligand on the leukocyte will bind a receptor on the endothelium. Then the receptor on the leukocyte will bind the ligand on the endothelium, and then the ligand on the leukocyte will bind the receptor on the endothelium, and then the receptor on the leukocyte will bind the ligand on the endothelium, and the process will keep on rolling like that. So this is the first concept. P-selectins are responsible for rolling, and then we will have this rolling leukocyte. We also have proteoglycans. Proteoglycans are very important for absorbing and helping bringing this supply of chemoattractants. These chemoattractants actually bind to receptors on the leukocytes, and like I said, cause cytoskeletal rearrangements towards the side of this of these chemicals. There is chemotaxis, which is the cytoskeletal movement towards a chemical gradient. So proteoglycans are involved with these chemoattractants in the chemotaxis process. If you're asked on the exam what is the use for proteoglycans, they are important mediators for the chemoattractants and the chemokines in the process of chemotaxis that causes cytoskeletal rearrangement and bringing the leukocytes towards the side of the chemical gradient, which is the site of the inflammation. As you see, the rolling will take place. There are very important proteins known as integrins. These integrins stabilize. Their function, they integrate and they stabilize and they adhere very solidly. So now no matter how fast and how strong the blood flow is, it can never uproot, it can never remove these leukocytes from their very strong binding with the receptors on the endothelium, and they can never remove the receptors binding the ligands on the endothelium or the receptors on the endothelium binding ligands on the leukocytes. And then that's why in chemotherapeutics sometimes there are anti-inflammatories, drugs that target integrins. These anti-inflammatory drugs, when they target integrins, they disable the process of rolling, because now the blood will just uproot, the blood laminar flow will uproot these leukocytes and they can never perform their function. The next step is actually a very important step. It's the actual process where we have PCAM. These PCAM proteins, if you are asked what are the PCAM proteins for, the PCAM proteins, they are very important. They are very important in the process of transmigration. So in order for the leukocyte, it has to leave the blood vessel. The leukocyte has to leave the blood vessel and migrate through the endothelium and leave. So this is a multi-step process of leukocyte migration through the blood vessels, and we have leukocytes, as we said, they are first rolling and cytokines activate them and they adhere to the endothelium, and we are at the step of the transmigration. They transmigrate from where? They migrate, so they leave the core of the endothelium and exit through the interendothelial gaps and exit through the extracellular matrix. They actually have metalloproteinases and proteases that destroy the fibrin and fibronectin in the extracellular matrix to pave the way for themselves to arrive at the site of the inflammation, so they can remove necrotic debris and have their combat with the intruder infective agents. So now when they leave, they keep on through chemotaxis, they keep on rolling and rolling to the site of the inflammation, and they begin to engulf these microbes, and they begin to arrive at the site of the chemoattractants, and they can fully perform their function. The last important thing that I would like to leave you with is that you have to understand that what's happening in the core of our blood vessel, what is happening at the core of our blood, what's happening at the core of these leukocytes and macrophages. Let's say the leukocyte has swallowed and engulfed these microbes and cellular debris. How does it get rid of it? It uses a reactive oxidative species. These reactive oxidative species destroy that engulfed material and digest it and break it down to very degradable substance. And then the lysozymes and inside these neutrophils, they have enzymes that will neutralize the proteases that destroy these engulfed material and bring it down into very neutral substance that may not damage the cell. That's why when there are genetic defects in the enzymes that are supposed to bring down the reactive oxidative species into neutral substances, like enzymes like superoxide dismutase and catalase that converts reactive oxidative species all the way down to peroxide, which is very useful for the cell. If there is a defect, then you will end up with a cell with accumulated lysosomes full of degradable and full of damaged substance that it cannot really perform the process of getting rid of it. So this is in a brief, the leukocyte migration through blood vessels, and we learned how the chemoattractants and these cytokines, they cause the mechanical gravitation of these leukocytes to the site of injury through rolling and with the selectins, and then stabilized by integrins, and then the transmigration with the proteins pCAMs, and then the continual degradation of extracellular matrix fibrins by metalloproteases that are in the leukocytes, so they can continue traveling to the site of the inflammation to destroy the microbes. And then after the reaction culminates, inflammation will either culminate and give us one of three outcomes: either resolution, and that is the most hopeful desired thing, or we can have healing by fibrosis or scarring, or we can move on to the even more dangerous step, that is chronic inflammation, where we will have macrophages more than neutrophils. So remember, neutrophils, they are circulating in the first 24 hours in the combat of the inflammation. After 24 hours, you will no longer see them. You will see the more that are slowly growing but more destructive, these macrophages. So thank you very much for your attention, and I'll see you in our next lesson.